All right, in the last episode, we talked about who does what during high-level design. While we worked on a platform-independent model, in this episode, we are going to transform this model into domain-specific languages. We're going to use Java, we're going to use C#, and we're going to use Python. So look forward to getting into this. We're going to start with Java, so let's get started. All right, let's transform the first PIM to a domain-specific language, and it's going to be Java. All right, so the first thing you do is they bring in the PIM as a pattern. They bring that into their environment. They may strip the global unique IDs. That's up to them. As long as they're working in their own environment and they don't contaminate the original design artifact. Now, the first thing that the developers or the application architect may do is say, you know what? We don't like calculate. We want to use get parameter or get area. And, they may change that. They may want to change the convention where it is camel and delimited by underscore. So they may want to do something like that, and therefore apply the notion of these method invocations as the approach that they do. And that's fine. An architect, a solution architect, or an enterprise architect should not get in the way of a development shop. This is one of the things that offended my development shops very much, is when an enterprise architect that was far removed from it's a chief architect is a different thing, but far removed from my development shop, the practices, processes, and the conventions that we use. That's the cool thing about model-driven development, is that you can make changes on the fly. Just make sure you're doing them early instead of later. The next thing they're going to do after they look through the nouns and the verbs, the attributes and the operations, is they're going to transform to the language that they want to use. So in this particular case, the language is set to none. They are going with Java, and they apply that to this element and then all of the elements. So all of the elements should be set to the language of Java. Once that's done, the next step is to come in on these attributes, and they're not real numbers. They're going to be using double. So they're going to go through and convert their attributes to the right type, right? So go through and do that there. They're going to do that everywhere within the PIM so that the alignment with the transformed code is correct. All right, so I'm going to do the rest of it offline. Okay, so now we're ready to do high-level design. And we're in this particular point. We're going to go to develop in this start in the develop tab up here. We're going to hit generate, and then let's just generate all right? So you get a dialog box that pops up that has all of the elements that are inside the model. And we're going to leave all of those selected. Synchronize model and code. We're good with that. So let's just go ahead and hit generate. Now, we've already generated the code to our configured repository. So that code is in its place and ready to go, and it has done that fast. Now we're capable of coming in, hit function key 12, and we're able to look at the code that was just stubbed out for us. Now this is high-level design. This is not ready to go by any means, right? There's things like, well, the developers are going to bring in their own notation, right? The developers are going to use their own approach to laying out how the code should be done within each file, class file, or element. And using Spark's Enterprise Architect, the finished product may look something as simple as this when they're completed. So they're implementing the interface, although it's named incorrectly. We have ours I-shape. So they would go through and do some fixing in order to align with the design. Or they may come in and say, well, this is not the convention we use for interfaces. We're good with just leaving it shape. and therefore that would be reflected within the source code. And you could do that at either end. You could do it within the code and then reverse engineering back where it changed this name here, or you could make the change here and sync with the code that's already been implemented there. So multiple ways to approach model-driven development from this perspective. With the coding that's been done in Sparks Enterprise Architect, including the main program implementation, we're now ready to go. So they would go to their repository, they would compile the code. So we're going to compile everything Java, check for errors, everything comes across clean. We're going to Java main and run it, and there we go. Everything is working accordingly. All right, in this next part, we're going to convert our platform independent model into a C# design. So what we're going to do is we're going to go to RAS, we're going to log into whatever your repository is, you're going to go to your storage area for whatever project, and you're going to version your design pattern or whatever you're referring to this design model as. Next, what we're going to do is go to the Sparks project instance where the design team is going to pick up that pattern and bring it in. So they're in the RAS, Reusable Asset Service repository. They've gone to the particular file, the pattern, the model that they're looking for. They're going to go to the namespace, the package in which they want to import, and they're going to select the package. They're going to select import, package and dependencies. Yes, I want to bring it in. It will overwrite anything that's already there, just as you've learned in previous videos. And now we have the platform independent model within this repository ready to work. Now, I wouldn't use Reusable Asset Service. Instead, what I would do is I would bring this in, Control, Alt, and I would import an exported version of the design package from a repository of my choice. And in that particular case, I might put it in a docs folder within my development repository, and then I would bring in the XML. And most importantly, I would strip GUIDs. I do not want the same global unique IDs as the original design model elements. So I'd bring those in and import in, and it is done. These elements with their own global unique IDs. If you did bring in the original GUIDs from a RAS repository or using an XMI import, you could then grab the elements that you're interested in this case, Control A and all. We're going to copy these and go to our own design artifact, and we're going to hit Control, Shift, and V to paste as new. This will also strip GUIDs. We're going to use or include the connectors. So let's go ahead and apply. And now we have those elements within our model environment with different GUIDs than the original design. And just as we did with the Java transformation, we're going to transform all of these elements to our target language, which is C# in this case. Next, what we're going to do is, because we have done this, we're able to go in, whether it's directly through the properties or through the features list, and I certainly would use the features window instead. I would convert these elements into their targeted type. So in C#, we would go to double as our type number, right? So we'll go through, we'll make sure that we have our types, our return types, our stereotypes, our scope, all that aligned with the target high-level design prior to moving into design and generating stubbed code. Next, we would go out and we'd stub out our code. So we're in the development tab, we're going to go to generate over source code, and we're going to generate all. You can see the classes that are in this model that we're generating and the repository in which they're going to be generated to. We would select generate, it is complete, and now we have stubbed out code for these particular elements. Now the development team would come in, look at this code, and make the necessary changes to transform it to a detailed design. Now you'll notice in this case that as the application architects and developers worked the high-level design and the detailed design, they were good with the conventions such as I-shape for interface that was used, as well as other conventions that were used. However, when they moved to their approach in C# from an object-oriented design perspective, they went with a particular approach that's commonly used in object-oriented programming languages for getters and setters. So in this particular case, the attributes are being formed using this access or accessor approach. Accessor method is what I meant to say, which basically transforms the attributes into properties. So when we're looking at the element now, the attributes are now properties of the class. If you look into features, they don't show as attributes, they show as stereotyped as properties within the class element. The same thing applies for circle. So this is one of the reasons why when you're moving from a platform independent model, you may see changes in how attributes and operations are shown within your models versus properties. And similar to what I did in the very first PIM to DSL video, you saw we were using the entity framework, which uses a similar form of encapsulation in their programming implementation, their language implementation. And you can certainly use Sparks as your IDE for developing and managing your code repositories, and then post that back to your actual working environment where your code is being managed within your IDE. And then from here, we're able to run the application and achieve the same results at a console level during testing to ensure that the application, the program, and the language is working according to design. All right, next what we're going to do is we're going to take our platform independent model and we're going to pass it off to the development team that is going to be using Python. And Python is a loosely typed, interpreted programming language that is known for its simplicity and readability. So it's a huge difference when you're moving from a strongly typed language like C#, Java, many more, to Python. And so what happens is you end up with very eloquent code. Here's the same objects that have been converted into Python, where your interface may look something like this. Very simple compared to how you saw it in Java or C#. Your class elements for rectangle and circle in this demonstration may look something like this as you're moving forward, or this as a single class element. The development team in this case said, hey, we don't need to have 3 different files or 4 different files, including the program file for Python. We're going to write it in a single script, and I'm just going to go ahead and launch it now. That looks something very simple to this. This is literally one file that contains your main and then your class elements for circle and rectangle and your interface. So very simple to do. So the stubbed out code was very simple for the team to transition into Python using the types and approaches known to Python. So now the team comes back after looking at high-level design. They deploy to their development environment. And then we just simply, the main file is called demo.py. and run it. And there we go. We have our results. So it's very simple to move from requirements to high-level design into detailed design and then demonstration. In this particular case, if you're the solution architect, it's pretty easy to choose which technology that you're going to go for based on this very simple set of requirements and the application that you're writing. I hope these sessions have been helpful for you in understanding how you can do model-driven development and the different approaches that you can apply to the stakeholders within your development teams. Thanks very much for watching. I look forward to seeing you in the next episodes as we move forward into more advanced subjects. And until then, happy modeling.